Hello, hello. Hello, everybody. Welcome. If you're here right now, even before I say hello, let me say congratulations. Okay, hello. Well, hello, Josh. Hello, everybody. Um, this is a complicated. All right, I want to clearly say congratulations if you are here right now. That is already an accomplishment, and I'm not being sarcastic. Bear with me for a second because this is. Oh, hello. Okay. And yes, I will properly say hello to everybody in a moment, but this is one of those moments. Bear with me for a second, please. Ay, okay, okay. Hold on. Coming. Okay. I'm just. Wait. Yeah. See, things are happening as we. One second. One second. Uh. Uh. Okay. Hang. Things. I mean, as you can imagine, there are exam-related things that are happening as we speak. So bear with me for a second, please. Uh. Okay. Hang on. I know there are people here. Is. All right, let me do this. Okay. 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 All right, let me start again here. Well, so first of all, hello. Hello. There she. Okay. Hello, Tiggy. Hello, Josh. Hello, people that still make an effort to show video. Thank you. And I know there are others of you. And I know today is hello, Josh. Okay. And I know today it's
Good afternoon, Professor.
hello. Yeah. Thank you. Hello, Laya Tule. I appreciate it. Thank you. And hello, Mira. Hi, Montserrat. Hi, Caitlin. Hello, Amelie. Hello, Jamie. Hello, Michael. Hello, Takarub. Good afternoon, Carla. Good afternoon, Angela. Angela S. I'm now realizing for the first time we have two Angelas. Bad on me that I didn't. Anyway, hello, Ali Rot. Good afternoon, Sebastian. And here comes Madonna. Album. Okay. Good afternoon, Sadie. Okay. I'm going to check one more time. I want to say a couple things. I want to make sure I'm saying them to the right people. Okay. So what I want, oh, more people. Um, okay. Well, okay, yes. Good afternoon, Sebastian. Good afternoon, Sadie. I think I said that. Or good afternoon, Madonna. Welcome. Okay, I see your note to everyone, Madonna. Well, all right. Uh, thank you. I'm saying thank you to Madonna. I see your point. But actually, oh yeah, well, I guess that's true. Okay, no, I do see. All right, well, here, okay. So look, the reason I'm sounding so all right. So here we are. Welcome everybody. There were two kind of important things. There was this exam that we were all supposed to turn in by 3:05 today, and then there was showing up to class. So first of all, if you're here right now, you've done something important. I mean, I think we all know it's kind of hard to show up to a class when something really big is due right before that class, or at least there's a lot of reasons for many of us that the big thing that's due right before class could possibly impair our ability to get to class on time. So if you're here right now, you have done something important, and there are certain people who are not here right now. If you're here right now, that means one of two things. It either means that you totally did hand in your exam and therefore you're here. And in that case, major congratulations. Hopefully, you not only feel some degree of pride, but also maybe some degree of relief that the thing is off your desk. We'll get into whether it was hard or not, or what, or how you did, but presumably it took more than a minute and wasn't always fun. So for those of you who did it and are now here, I very seriously congratulate you, and I hope that you take some pride and some relief in that fact, no matter what happens next. Now, let me also say that anybody who is in the room now, who's for whatever reason not done with the exam or ran into an issue or either did or did not communicate with me, and that falls into a range. I will say, having been a student or being a human being, that if you're not totally done with it yet, but yet you're able to face the music and show up and be here and also possibly, and I hope, well, if you're able to do that, if you know that something is a little bit not perfect in your universe right now or in your universe with me, and yet you're here and you're facing the fact, or that also deserves its own kind of congratulations. And I don't mean that sarcastically either. At least for me, I know when something is not perfect, I am much more likely to avoid than confront. So if you're here right now, especially if you're in a bit of a spotty situation with your exam, then I do appreciate that you're here. And I do think it's noteworthy. And I think it's meaningful to your colleagues, whether they know who you are or not. I think us all showing up here is important, really, and not necessarily easy for all of us. So thank you. And I do mean that seriously. Wait, okay. And I'm, even as I'm saying this, oh no, that's all right. But even as I'm saying this, I'm acknowledging there's a couple of exam issues outstanding right now, which is, is not ideal. But and even as I'm saying this, I'm sort of getting some private comments and some emails about some situations. Okay, so all of that will be dealt with. So I don't have one uniform message for this whole group. I will say that if you are sitting here right now and listening to me at all, you're already doing something that might not be totally easy or fun. So you should take some satisfaction in that fact, for real. I will further say, wait a second. Okay, but I am, as I'm saying this, honestly, I'm getting like direct chats and I'm getting emails. So bear with me for a second. Hang on one second. I would like to have for as many of you as possible. I would like to have this thing like resolved and put to bed, and I would like to have the ball in my court, not yours. So bear with me again for a second. Let me just see someone's. Um, Actually, yeah, bear with me more. I'm sorry. I'm going to stop saying I'm sorry, but I'm not going to actually. Um, okay. Right. So first of all, I think being here right now is not necessarily easy for everybody or fun. So congratulations. And again, I mean that. Second of all, I did. Now, second of all, there's at least one person in the room who, at least one, maybe two, who saw that a legitimate issue, like that saw a couple days ago or a day ago, that something was going to happen with their exam, and then they reached out to me, and so we made an arrangement, and they have an official extension, and that arrangement or that possibility is open to any of you on the final. I just want to be clear, like that's not if any of you, when we get toward the final, which is also take home, same deal. If you know, and especially if you're not the same person, if you're not doing this all the time, if you anticipate an issue with the final and you reach out to me in advance, well, I mean, it's with the final, it's trickier because like the whole semester ends and we run out of, but I mean, if you need a couple of hours or something like that, or something is going to go on and you reach out to me, then I'll honor that, because it's like communication is a big part of this whole process. Okay, so that said, it is the case that within like the last hour and a half or so, a number of communications have come in. Not a number, but some of you have communicated some difficulties or some issues like in the last hour and a half or right when this thing was supposed to come. That's a little harder for me to deal with, just to be honest. Like that's why I'm sort of starting the class in a kind of a slightly more confusing way than I had intended. I mean, to be blunt, I was sort of just hoping to congratulate all of you and to move on. So let me just say, as honestly as I can, or as uncritically as I can, if you ran into difficulties or if you discover difficulties in the last couple of hours with your exam, that is slightly short notice to expect me to realize and do anything about. I mean, to be honest, like that's a little tight. And I want all the people in the room who did their exam on time to understand that their efforts were not pointless or wasted. So at the risk of being too public with any of this, if you happen to be in the room right now and your exam is not done for whatever reason, and if you did communicate with me in the last couple hours, that is certainly better than not having communicated at all. It certainly is. And what I want to say to you people as a whole is, please don't be working on it right now. I mean, this is like the one time where the lack of video is a little strange. Like, don't be working on your exam right now. There's nothing I can do to enforce that. I'm just going to appeal to you as human beings and say, if you want me to meet you halfway, or you want me to show like compassion and mercy on the fact that life is life, I can do all of that because life is life, but let's meet each other halfway, and let's not be using class time right now to scramble or to try to scramble. I will read everybody's exam. I will read everybody's exam. Everybody will get credit for having taken this exam if they take it. Okay. Nobody's going to get a 0 for having missed the deadline by a minute. Like, and hopefully that reassures some of you. And so you will all get credit for this exam. If the exam is later than 3:05 and I didn't know that that was going to happen, I do have to tell you all as a group. I mean, I'm saying this as much for the sake of the people that are in the situation as for the people that are not. If it didn't come in at 3:05, there will be points deducted. How many are like not enough to fail you, not enough to crush you, but enough to make a difference, you know, to make a difference. How many points exactly will depend on the situation. So if you communicated with me at all, that's good. That's a start. What's going to happen after this class is individually, I will communicate with the people that have different issues, and we'll see what the situation is. At least one person was telling me that they could do X, Y, and Z and PDQ in the exam, but they had a real issue with one portion of the exam. I think if you have most of your exam, it would behoove, well, I mean, in the future, what I would say is if you have most of your exam and you can turn in most of it on time, but you have a particular issue with a particular thing and you want to make a particular arrangement about that, even with some small penalty or something, it's probably best to approach it that way. Like, I do think, I just have to say, like, any exam that just came in on time is going to be treated slightly differently from any exam that, or any document that came in on time is already going to get looked at in kind of a more, in a less prejudicial way than an exam that didn't come in on time. I don't want to dwell on this, but I also just want to make this clear before the final exam happens. I think the best advice for your future, for this class, for life, is like, get the thing in and then tweak. And then if there have to be detailed discussions afterwards, you're in a better position to have those discussions afterwards. So, but anybody who's asking for more time or who needs more time, the worst thing that's going to happen is I'm going to take off more points than you would have preferred. But I will take the exam no matter what. So, this is a too long way of saying I'm not going to respond to all the individual emails right now. I can't make the arrangements right now. You'll have to bear with me and be patient. So I would also say, and again, the one thing I don't want to happen right now is people working on it right now. I can't even explain why, but I just think that is not nice. If you've got a substantial document that you think has something missing that you want, but if you've got a substantial document, I would say upload it now, and walk away from it for right now. If you don't, psychologically walk away from it for right now and know that we'll deal with this later, and you're not going to fail or anything like that, or not for this reason or anything like that. Okay, wait, I'm looking at the chat. Okay. Oh, weird. Okay, wait. There's a lot in the chat. I'm sorry. Hold on. And I don't mean to be all weird about this, but it is weird, right? Because, well, it is weird. It just is weird. Hold on. So I'm looking again to see where we're at, and then we'll go on. Oh, and for what it's worth, also, let me wait. Can I? Yeah. I do care, as you can tell. Especially with an exam that's arranged the way this one is. It's such a weird arrangement that I think it is important to respect the boundaries where they are. But I know they're hard to see in a class like this and so forth. So let me also say, do I think it makes a difference whether something's on time or not? Yes. Does Google make it clear whether something was put in on time or not? Yes, it does. It does. Can I look further and see the difference between 3:07 p.m. and 11 p.m.? Yes, I can. Like Google makes that clear too. Do I think that makes a difference? Yes, I do. Like I know. I mean, I do not think 30. I don't think 307 is the same thing as 304. I don't. But I don't think it's the same thing as 11 p.m. either. If you know what I'm saying, okay? Like, so that's why the number, I don't have a rule like that you lose X points if it's late, end of story. It's more nuanced than that. But I just need the people in the room who did do whatever they did to get this thing. I need them to know that that was worth it on their part. It does make a difference. And I also need the people who could not get in in time or did not get in time, that they will be treated with mercy. They will. You will. Okay. Your life is not over. The course is not over. You don't fail or something. There's not, it's not you know what I'm saying. But I'm just looking one more time before I move on to see like where we're at and what's in and what's not in. Okay. Okay. Now for all of this, okay, and everybody is in the room. Well, just about everybody's in the room. And again, let me say, as long as you're in the room and you're hearing all this, this will not be the end of your academic life, I assure you. Okay, I think I'm about to move on. I will. Can I? Oh. Oh. Okay, wait. So there's a couple of things in the chat that are sort of more. One person in the chat is asking, was the last question, was it worth more points than the other two questions? Well, I mean, I think accidentally it might be because there were more parts. Like more or less in this exam, each sub question is generally worth an equal number of points, like 2 or 3 points for each thing. So to the extent that the last big question had the most parts, yeah, I guess they did add up. So it wasn't so yes, I guess so. Also, you know, I think the last part was kind of the most exam-y part of this whole exam because it was the newest and you know, we hadn't gone over it 400 times. So yeah, I mean, I guess it was worth more points, but I think that's the answer to that question. I will also, so again, yes, if someone's explaining why they turned it in at 306, like, okay, I appreciate that, but I can see what time it came in. One person said, so I'm going to move on now. Well, if you did, oh yeah, wait. And so someone else is asking, okay, so I can get to this because I know I do sound I don't know what I sound like right now, but I'm sure it isn't pleasant. Someone's asking, are we still getting the additional points if we did the assignments added to the exam? I'm going to read that word for word because I'm sure many of you care about this question and I might be misunderstanding. The question says, are we still getting the additional points if we did the assignments, comma, added to the exam? So that's a very important question. Well, okay. So I think the answer is yes. Like any homeworks you did, and you can still be turning in homeworks, any homeworks you did, and especially all the game participation stuff, which some of you do like a lot. That's great. And all of you still can do whenever they're applicable. All of those points you absolutely get no matter what you did on this exam. And in fact, that's kind of the point, is that they along with your lab experience and your lab grades, they all are meant to provide a huge cushion and a huge context so that your final grade is not entirely determined by 1 or 2 exam grades. Like the simple answer to your question is, and that's why you've all been, I hope, that's why we hang together in all of these Zooms and why I try to make a big point of like how much we can talk or participate or ask questions and blah, 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 in all of these Zooms and all the outside, because your final grade is not just determined by your exam grade. Definitely not. The only reason I'm pausing on, so I hope that's encouraging. And look, in my other classes, I usually have to make a big speech once this midterm comes in about, don't worry, even if you get a 71 or a 65 on this midterm, that doesn't mean you're getting a D or a C plus in the class. That is also true in this class. the truth of the matter is most people that actually do this midterm in 102 and take it somewhat seriously and sort of do it on time, usually people do fairly okay on it. Like it's, for whatever reason, 102 is kind of a special class for a variety of reasons. People tend to not, the grades tend to be okay, So it's not even, I mean, I think I don't even need, I hopefully most of you who did it are not actually panicked about what number you're going to get. We'll see. But yes, all that extra stuff counts. However, I do have to qualify just to make, well, yeah, wait. Okay, wait. So there's more coming on in the direct chat. Hold on. Okay. So the person in direct chat is specifying they mean a specific homework, like the homework where I asked you to write about the videos for the class that I missed. I mean, that my answer is still yes. Certain things like that, it would be better to do them like right when they happen, because the whole point is, did you see the video like when it was relevant? If you actually did it and you got the points, oh yes, your points are counting. Absolutely. But if you're implying that you missed that one and you didn't do that homework, I'm not quite sure what to say about that. But let me, and maybe you should tell me whether I'm clearly answering your question or not, but let me say to everybody also, because everything in this class, it's a little unusual for a science, or aspects of this class are unusual for a science class. I know that, and that can be confusing because I know I'm really soft about, or unexpectedly soft about certain things, but then maybe unexpectedly rigid about certain aspects of the exam. And maybe it takes a little while to get used to that. But all those game turns and all those points and all those homework points, they don't get added. This is the one thing I want to clarify. It seems confusing in that question. All those extra points that many of you are pursuing with a vengeance a lot of the time, like all those extra homework points and extra participation points, they don't get added to your exam. They get added to your final grade in the class. Like they're meant to directly help your entire grade, not just your exam grade. Now they don't get added one per one. I mean, it's like for every 1 point that you earn in all that stuff, like it turns out to be like 1/5 or 1/10 of it goes onto your final, but it is a correspondence and they do add up. So like they go on your final grade. They don't go on the exam grade. I don't know if that's, and I think that's ultimately good news, frankly, but I don't know if that's good or bad to you, but that's the answer. Okay. So I'm answering it clearly. Okay, cool. Now, someone else in the direct chat is, they're saying in the direct chat, like note to class, submit homework. Yeah, I mean, and yes, even homework that you haven't submitted yet, if the portal is still up, if it's, do it. Yeah. Okay, wait. So I'm just going through the direct chat. So, okay, I think that's everything. So that we can move on. Oh, wait, here we go. Sorry, one. Well, so that we can move on is 5 minutes ago, what I said about the general exam status and the coming in on time or the not coming is all that. Can you just raise your electronic hand if it's clear what I'm saying about the okay. All right. Thank you. Okay. Thank you. Awesome. Thank you. Okay. Thank you. Okay. Good. All right. Cool. Oh, okay. Cool. Thank you. I see you all. Okay. Great. Oh, okay. No, great. All right. Thank you. I saw you. Okay. There's another question. Yeah, you can put them down now. Thank you. There's another question in the direct chat that says, what would I say is the maximum points you could earn from the participation assignments, game points for the final grade? That's a very fair question. Very important question. And I think I've mentioned this in earlier videos or classes or whatever, but here, okay, it changes every semester. Like I can't like literally say exactly what, but I can tell you that in a typical semester, I've seen people earn up to 14 points, 14 percentage points on their final grade from all that homework participation stuff. Now that is the upper end. Like that, I would say the average is like 8.7 or 8 points on their grade, on their final grade though. And as you know, 8 points is a lot, right? Like that's like, I mean, 8 points is like can be from like a B- to an A- or whatever, a B to an A or something. And that's not atypical. but I have seen it as high as like 14 points. It can be huge. It can make a big difference. That's the idea. So I don't know if that answers that question, but and of course there are people that earn nothing from them because it is all technically optional. Like you don't, but and look, and also people generally do well on the exams in this. Oh, okay. So I don't mean to sound so. I'm partly sounding this way because I mean, to be really blunt, I just almost wish that everybody in the room were kind of in the exact same place so I could just talk to you all and give the same message. It's a slightly different message. And I imagine that some people in the room are a little bit maybe nervous or frustrated right now. I mean, the last thing is, and we will move on. Like, I think my experience is that an exam that is open world like that and take home and where you even get walked through the exam in advance and you get help with some of the answers in advance. I think there's something almost deceptive about an exam like that. I think it feels like it's going to be a total gift and a total joke. And it feels like something that one can render as very low priority, or I would certainly. I mean, I would get to that last out of all the responsibilities I have as a science student. And in part, that is the intent. Like, we're not actually trying to give you more stress in your life. We're actually trying to find a way to give you some education in a less stressful way than the rest of what you do in your science life. Like, honestly. So it's totally not surprising to me that an exam of that nature, many of us would kind of like sweat less over and maybe leave to the end. But what I've also found, or what I hope that maybe some of you found, what seems the fact that there's like a number that right at the end, there's a number of people who are like, whoa, this thing was, I thought I understood the material, but I didn't, or this thing was like longer than I thought it was going to be, or whatever. Like all of that, none of that is surprising. None of that is upsetting. None of that is appalling. Like that is all life. But what it does indicate to me is that hopefully it indicates to me that to some extent this exam does examine something. Like I did get one comment in the chat, which, I mean, if it's even 10% authentic, then I'm kind of thrilled. One person wrote, very much in private, wrote, it was kind of fun writing the midterm as a project in a weird but satisfying way. I mean, that person might be being very polite, and I understand, or like on a tense day like this, they might be just trying to calm me down, which I appreciate. But like, if there's even 10% truth to that, that is what we're hoping. Is that, I mean, no, work is never fun. But if like writing this thing out when you kind of think that you know it, and now you're getting to explain things that you think you kind of know, and you're getting to drag them out and expand them and teach them, we are kind of hoping that an exam like this is kind of weirdly satisfying. Maybe emphasis on weird, and maybe satisfying in a very limited way. But the hope is that when you're done with this exam, it is more sort of a report of something that you've learned, and that when you could stand back and look at it and feel like, oh, I actually did learn something, and it wasn't that stressful, but it seems like I now know some concepts that I didn't know before. Like that is the hope. And it turns out that maybe that does take a little bit more out of us than maybe some of us would expect. Like, so, I mean, in part, this happens every time that at the end, people are like, oh, that was actually a slightly bigger deal than I signed up, than I thought. So if nothing else, I hope it was. I mean, I hope it wasn't more stressful, but I hope that you got something out of it, or that you're feeling like you're learning something in this course. The final will be very similar. You'll have less time because, we have to get our grades in and all of that, but it'll be a similar experience. So bear that in mind, I guess. Okay. There's more all right, someone's saying in the direct chat that it was more tedious than I realized. I mean, I don't even know what. Yeah, I tried to cut down on it. There is a lot of repetition and there is tedium in this exam. That's not what I'm hoping. That isn't really the goal. But yes, it's true. We tried to cut down on that. But yes, I imagine that's true. I will also say though that to the extent that there's like a lot of little questions, we're trying to show you too. This is the way physics, if you just phrase physics questions as here's the situation, what's the velocity or whatever, they really can be overwhelming and people don't know where to start and all that kind of stuff. We are trying to show you that even the biggest, most abstract seeming physics questions, if they're broken down into a series of small steps, they are far more manageable than they might seem. Or put one last final way, this whole course may be a bit tedious, especially on Zoom. and I apologize for that. But I will say, if you step back, what we are trying to do in this course, and we've mentioned it before, and as we get closer to the final, you will see, the course is meant to show you that through a series of small and perhaps tedious steps, our minds, human minds, can move from statements, beliefs that are self-evidently obvious to statements that are completely surprising. Like, honestly, specifically, this course is meant to show that if we go from the belief, that the earth moves and yet we don't feel it, to the belief that like things don't change their velocity unless they're forced to, i.e. F net equals ma, to the belief that like elasticity means harder to move as you move it more and more, right? We're like, if this course is tedious at all, and I'm not trying to be defensive, even though I totally am, but tedious means boring, right? Means repetitious and boring. So if each of the little steps that we're looking at in this course, each of the motions that you look in the lab, if each one seems a little bit tedious and boring, that's bad, but it's good because it means in a way that each one of the steps is clear and obvious in a way, right? We get bored of things once we feel like we know them. What we're trying to show ultimately is that all physics does is take you through a series of steps, each of which is small enough to be boring and simple and self-evident, but somewhere along the line, by going through enough of these, enough of a logical progression from small, tiny, self-evident step to next small, tiny, self-evident step, then eventually we get to places that are completely unexpected, such as the universe is expanding, which actually is one of the major punchlines of this whole course. Like, we want to show you why people believe the universe is expanding. And let me say that if you think it's obvious that the universe is expanding, that is only because you've heard the statement so many times in the New York Times or whatever that you feel accustomed to it. But it's actually a completely crazy statement to make. To say that, I'll just say right now, just because now I'm going to start moving into physics. You may have gotten used to the belief that the universe is expanding. But before you get too used to that belief, let me remind you that when people say the universe is expanding, they don't just mean that objects are getting farther and farther away from each other. That alone is actually interesting. If that's true, that we believe that stars and planets and galaxies are over time getting farther and farther away from each other, even that, I don't like, why would we believe that? And why should that be happening? And why should we be so confident that it's continuing to happen on scales that are way beyond anything we've ever experienced, time scales that are beyond anything we've experienced? That alone, but when people say the universe is expanding, they're saying something much crazier than just that. When people say the universe is expanding, they mean literally the space and time fabric, the space and time coordinate grid, the space and the time of universe, are getting bigger themselves. Not just that objects are occupying more and more of the space, that would be one thing. But when people say the universe is expanding, they mean the space of the universe, the size of the universe is growing. But the universe is supposed to be everything. So if the universe is growing, if the size of the universe is expanding, into what would be, I think, the next natural question, right? We're not, when we say the universe is expanding, we are not just saying that the contents within the container are taking up a higher percentage of the container. We're saying the container is getting bigger. What the heck does that mean if the container is everything? Bigger compared to what? Bigger into what, right? It's a crazy claim to just find self-evident. Now, the point of this course is not to prove to you that it's true or to force you to believe that it's true. But the point of this course is to take us through enough steps that start with like simple, boring, dumb springs, turn springs into waves, turn waves into electrical waves, turn electrical waves into light waves, and from light waves, make some inferences about why people would come to this crazy, almost like nonsensical conclusion that the universe must be expanding. This course is meant to show you how we get from step A to step Z in that syllogism. Again, it doesn't mean we're right. Doesn't mean you have to believe it. But at least we want to show you how physics thinking works in that way. And how physics thinking works is it breaks down big questions into tiny, tiny steps that are so manageable and so irrefutable that on the one hand, we have to accept them. But on the other hand, they're boring by the time we do accept them. So this is all my big defensive response to the. So the exam was a little bit tedious, and I apologize for that. We're trying to make it less tedious. The course is a little bit tedious, but we're trying to show you how crazy, how it's possible to get from tedious to surprise. We believe in an expanding universe. We believe in things like black holes. We believe in things like twins getting older than other twins if they go off in rocket ships. We believe all of that not because we watch too many Harry Potter movies, but because we think all those crazy illogical conclusions follow logically from observations, measurements, and self-evident truths. That's what's cool about physics to me, that it moves us from the obvious to the surprise in a slow and steady enough way that we can't argue. I mean, we can, but that we don't want to by the time we're done. So, but yes, I think the exam. So anyway, so we're just trying to give you a flavor for that, and the ideas are crazy enough and hard enough that we feel like we don't have to ask you to memorize them, just to even be able to sift through them and report on them, hopefully is an experience enough for both of us. Okay, so that's my whole, so we're going to go back to physics in a second, but, Oh, well, thank you. Oh, okay. Thank you in the direct chat. Cool. And for what it's worth, the final exam will even more directly than the midterm actually ask you to put this stuff together. I mean, it is a story. I mean, it does have a beginning, middle, and conclusion. Anyway, but thank you if that meant anything. Okay. Now, the other thing is, so we're going to move on. I promise we're going to. But the other thing about your exams is also, I always get stressed around exams. One of the reasons we do this the way we do is because, I still find exams very stressful. I don't like watching other people go through the stress. I don't like the stress. I didn't like it when I was a student. And by the way, I also don't like grading them. So on that, just so you know, every semester, I try to organize things so all the exams don't come in from all my classes at the same time, but somehow I always fail at that. So all my exams just came in from all the classes. So now the ball's in my court. Okay, you just had your suffering. Or some of you are just about done with your suffering. You should feel congratulated. You should feel proud. You should feel relieved. You should not even stress too hard about whatever homework I posted for next week. We might even get to a lot of it today, maybe if I ever stop yammering. In fact, I'll probably even, right when this is done, I might even just change the date on homework so it's due in 2 weeks, so you have a little time to breathe, maybe, because you deserve it. But now it's my turn to deal with your exams, and I got to tell you right now, I will do everything I can to get them back as fast as I can, but it won't be fast enough. I am communicating to you right now. I will not get these exams to you as fast as I want or as you want. Of course, my goal is next Thursday, but that's my goal with all the exams. I don't think it's going to happen. I will try my best, but just please be forewarned. They're obviously not multiple choice exams. I can't stick them in a Scantron machine. Also, no, you're just going to get them back through Google Classroom. I'm not going to wait for a class period and turn them all at the same time. You'll get it. So I'm going to do them as soon as one is done. It'll just be sent back to that person. If one of you gets an exam before another person, that reflects more where your name is in the alphabet than anything else. It doesn't have anything to do with perform. I mean, I will do the ones that came in first. I mean, the ones that came in on time, the ones that don't say late on the Google Classroom will be done first. That much I can tell you. But beyond that, if one of you gets one back and another one hasn't yet, please just be patient. Bear with me. It's not personal. I'm just doing them best I can. We will go over them to some extent once you get them back, but there's 1,000 reasons it's not beneficial to do that before you get them back. But yeah, once we get them back, and then there may be even an opportunity, depending on the score, we'll talk about the scores when you get them back. If there's huge pain and suffering, we'll do something there'll be an opportunity to redo a question or something for extra credit, or say if need be, it might not even be necessary. We will go over it to some extent, but not before I've had a chance to look at them and gotten all of them. But yes, I'm just answering a question in the direct chat. Okay. Oh, okay. Okay. I'm seeing the direct chat. Okay, cool. I'm glad. It sounds good. Okay. So that's a lot on that. I keep forgetting. I gotta remember to pause the recording, and you just never know I just never know when I'm going to be substantive. It hasn't happened yet, but just in the off chance that I ever say something of value, I'd like it to stay on the recording. But okay. Let's shift gears now. I mean, if there's any, yeah, I do want to see. I mean, if there's anybody that wants to get something off their chest about the exam, I'm almost please feel free to put in the chat, public or private. And if you want to go public and you want me to, but I feel like probably most of you feel like I've said enough about nothing. Okay, so what I want to do, I want to start talking about electricity now. I want to start talking about electricity, which my belief is that 2 days ago, no, wait, 2 days ago, you had the optional makeup. Oh, about how many, raise your hand, raise your electronic hand if you did show up on Halloween to the optional makeup lab set. One, oh, okay, John, was John, raise, oh, yeah, keep them up for a minute. I'm actually really curious about this. If you showed up 2 days ago, oh, Tiki did. Okay, I thought she did. To Carla, Mohammed, okay, anybody, keep them up for a second. Was it, is that right? It was about 4 of you? It was just, no one, okay, wait. Raise your electronic hand if you're hearing me right now. We are actually going to start class. Raise your electronic hand and keep it up if you're hearing me right now. Okay. Okay. That's cool. Okay. Okay. So, okay. Thank you. So most of you did not go on to, okay. Okay. All right. Thank you. You can put them down now. That's good. Thank you. Am I correct that 2 Tuesdays ago, you did a lab regarding electricity or electrostatic? You did a computer simulation lab regarding electrostatics. Is that correct? Yes. Yes. Okay. 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 Good. Now I want to start giving you so that's where we go for the, we're going to be on electricity for a little while now. This brings us to the next unthingy thing in this course. Like wave motion is the first unthingy type of motion, the first type of immaterial, non-particle, non-particular motion. Ultimately, electricity involves two type of unthingy motions, neither of which you've seen directly yet in lab, but the two unthingy aspects of electricity that we're going to get to here are electrical currents. You'll do that in lab next. Like electrical currents running through wires. Whatever an electrical current is, it ain't thingy. I can tell you that. I mean, when a current runs through a wire, there is no object that's running through that wire. Or certainly if a current goes from one place in a wire all the way to another place in a wire, or if a current goes from one device, like a battery, to another device like a light bulb, I can assure you there's no individual object you could possibly point to that's going from the battery to the light bulb. Even if you're under the belief that electrons are moving in there in the wire, and they sort of are, there's no individual electron that's making a journey from a battery to a light bulb. So electrical currents, which we're about to get to, are certainly an unthingy thing. But the other thing that's unthingy about electricity is electric fields. And that's really where I want to start taking the discussion in a lecture as to what exactly an electrostatic field is. And the best way to understand an electrostatic field, or one of the better ways to start understanding what an electrostatic field is to relate it back to to what we call gravitational fields. So here's what we're going to do. I think because I've been yammering so much, for good or for bad, I think the best thing we can do right now is I'm going to show you what your homework that's due next week, ostensibly, is meant to take us on a comparative journey from gravitational forces to electrostatic forces to electrostatic fields. It's trying to show us ultimately what the nature of a field is by building it up from an electrostatic force, and it's trying to show us what the electrostatic force is by comparing it to what we kind of think we might already know or could relate to about gravitational forces. That's what the homework is about. What I think we're going to do right now is start the homework. So one way or another, we have a more relaxing week than last week, or that you do. So I am going, so the homework, it was posted like an hour before class, but it's in Google Classroom. I'm going to switch screens from it so you can see it. And hopefully you can take it out. Okay. I'm going to make some comments about it. And in believe it for good or for bad, wait, where to go? Okay. This is the homework that was recently posted that ostensibly is due next Tuesday. Maybe next Thursday. Maybe I'll change it to 2 weeks, but either way, don't overstress it. But this is a homework. It starts at the top of the sheet. It starts with an equation that supposedly from Physics 101. I'm not sure if that actually applies to everybody in the room, but at the top is the equation for the force of gravity exerted by any one point mass on to any other point mass. Wait, sorry, Takurub, and Carla, are your hands up from before, or do you have questions? Sorry, if your hands are up from before, you can put them down now. Okay, sorry. And Carla, same thing, or is okay, thanks. All right. The assumption here, the assumption is that, well, no, I guess the belief that we have since Newton is that if you have any one bit of mass over here separated by a distance r by any other bit of mass 2 over here, that automatically and necessarily mass 1 will pull on mass 2 with a force, with an amount of newtons that is fully determined by how big mass 1 is, by how big mass 2 is, by how far apart they are, and by this universal number, this universal constant known as the gravitational constant, known as capital G, and which in fact is not defined in this sheet. So I'll write down for you on the board in a second. The first big idea behind gravity, and this is universal, right? This is saying any bit of mass, m1, separated by any distance at all, by any other bit of mass, m2, automatically pulls on the second mass. Multiplication is commutative. It doesn't matter what order you write multiplication in. And also there's this thing called Newton's third law, which says that if I pull you, automatically, necessarily, you pull me with the exact same strength, but in the opposite direction. So I'm bringing up those 2 points to say that if you take the idea of gravity seriously, it doesn't just go in one direction. Any bit of mass in the universe necessarily, automatically pulls on any and every other bit of mass in the universe at all times with a calculable, measurable, predictable number of newtons, according to this law of gravity. It's a fairly big claim to be making. All things pull on all things at all times with specific numerical amounts determined by how big the things are and how far apart they are. The bigger things are, the more they pull. The closer they are, the more they pull. That's what that equation is trying to say. Okay. And again, supposedly it's from Physics 101, but I don't know how new it is to some of you. The couple of details in that equation, and the reason we care about gravity, why I'm suddenly bringing up gravity, is it turns out that bits of charge, protons and electrons, pull and push each other in exactly the same mathematical way. The idea is that if we already have some experience with this idea from the mathematics of gravity, then we carry over the exact same math to the mathematics of electrostatics. And the idea is that it's a little bit easier to picture with masses, because masses can be macroscopic. The idea is that you have some notion of gravity because you see things drop toward Earth all the time, and you have some belief, or we all have some belief or understanding that, like, whatever it is that's pulling things toward the center of Earth is the same force or the same phenomenon that's pulling the center of Earth toward the sun, or the center of the moon toward the center of the Earth. And we can picture, even, I mean, to some extent, we can picture the Earth, and we can picture the moon, and we can picture the sun. It's a little bit harder to picture electrons and protons. It turns out they all behave the same way, or roughly the same way. So we like to remind ourselves of what we think gravitational bodies, known as masses, are doing before we dive into what charged bodies are doing. Okay, so that's why this equation is the first thing that's written on your homework, is the gravitational equation. I want to delineate a couple of details about it, though. First of all, that number, that capital G, is a number. It's a universal number, never changes. If you can, it happens to be 6.6. You could write this down. That would be great. It happens to be 6.67 times 10 to the negative 11th. I'll say that again. Capital G equals 6.67 times 10 to the negative 11th newtons times meters squared over kilograms squared. I should be able to. Well, I'll say that one more time. Capital G is equal to approximately 6.67 times 10 to the negative 11. And then the units are newtons times meters squared over kilograms squared. Those are the units of G. Now, I think it's worth writing down, as you just did, but there's a reason I didn't write it into the sheet. First of all, you're not going to use it when you're doing electrostatic calculations. But second of all, I want you to notice that the units of that capital G are like really weird units. Newtons times meters squared divided by kilograms squared. They're so weird, you might ask, like, how do I even remember them? Or like, why do I even remember them? Well, they look weird, but what they really are, if you think about it, they're designed to cancel out the units in this equation here. This equation says that the gravitational force is produced when you multiply the kilograms in one mass by the kilograms in another mass. Like gravitational force is directly proportional to the mass of each interacting object, and it's inversely proportional to the square of the distance between the two objects, the distance being measured in meters. So this long weird thing that so you notice in the top of this equation, what you have when you multiply masses together, you have kilograms squared. And in the bottom of the equation, when you square distances, you have meters squared. So the capital G, that obscure number that I just told you, the whole purpose of the number and of the constant is just to scale things. It's just to cancel out the kilogram squared in the numerator and to cancel out the meter squared in the denominator, so that we're left with something, with a force measured properly in newtons. That's the purpose of the number. If we weren't, so it's just a scaling factor. It's like a conversion factor. It's always true, but the number is only significant insofar as it arranges things to keep us in SI or MKS units. It's a proportionality constant that scales everything to the scale that we like working in. If you're willing to work in a different scale, you put a different number. Or if you're willing to really arrange things really specifically, you could define that number to be 1. Okay, so the G number is a constant proportionality that just ensures that everything ends up in metric units. So the concept of the equation is that gravitational attraction between any two objects is directly proportional to the mass of each of those objects, and it's inversely proportional to the square of the distance between those two objects. That's the concept. You'll see, it says this in the homework, or it says this in the Google Classroom, you'll see an R with a hat at the end of the equation. I mean, with a hat. I mean, that's what physicists call it, but an R with a caret over it at the end of the equation. I'm going to tell you right now, that has to be there. That is technically correct. It signifies that this whole thing is a vector and it has a direction, that the whole force is a vector and all vectors have direction. That R with a caret over it signifies the direction, but we actually don't have to get too bogged down in that to do any of the calculations we're going to do. So I'm telling you right now, I mean, it says it in Google Classroom, but whenever you see R with a caret over it, assume that it's indicating direction, and correctly assume that its value, its magnitude is 1. So it does any multiplication that you're doing with numbers, it doesn't change that at all. So essentially, you can ignore it whenever you're doing calculations. That's sort of because it's going to appear in the other equation too. Okay. The one thing, well, the one thing that it's really there for is to allow for the following convention to make sense. You'll see a negative sign before the entire equation. That negative sign means attraction. It means it's a pull. Gravity always technically has a negative sign there because gravity is always a pull. The force that M1 exerts on M2 is in the direction of negative R. That R hat thing. Okay, so I'm going to explain the R hat thing once, just so that I'm not like lying to you or leaving you in the dust, but you don't have to get, if this makes sense what I'm about to say, then great, then the whole thing will be clearer to you. This is like pro tip, intellectual pro tip. I'm going to explain this once, but if you don't like it or it doesn't work for you, it's okay. You can move on with your life. The R hat, the R, we call it R hat. That's so stupid, but that's what we call it. The R with the caret over it, okay, is a vector whose length is 1 and which is defined to point from mass number 1 to mass number 2. Okay, it's the direction of the vector that points, the displacement that points from M1 to M2. Okay, so this whole expression here is technically telling us the direction of the force that is exerted by M1 onto M2. The M1 and M2 are arbitrary. They're any two masses we want. But if M1, say, is the bigger mass, and we're focusing on what the bigger mass is doing, it's just a choice that we're making. If we're focusing on what the bigger mass is doing, M1, our displacement vector, by convention, by choice, is a vector, is a displacement arrow that points from M1 to M2. At the end of the day, this whole force called gravity supposedly points in the direction of negative R. Like the negative sign at the beginning of this equation says to you, we're going to calculate a force that we're going to start in our minds that it points from M1 to M2 because we're trying to calculate the force exerted by M1 onto M2. So we look at some arrow in our mind that is drawn from M1 to M2 because we're looking to see what M1 is doing to M2. But at the end of the day, this law, this discovery of gravity says at the end of the day, we put a negative sign on because at the end of the day, the force that M1 exerts onto M2 is actually pointing back from M2 to M1. If we were picturing in our mind a vector that was pointing from M1 to M2, the negative sign says flip that vector and point back at M1 because this particular force known as gravity actually will pull M2 toward M1. It's an attractive force. So whenever you see that R symbol in a force, that R with a caret, and then you see a negative sign, together what they actually mean is that the force is attractive. The force that I exert on you pulls you to me. Okay, and if all that went over your head or was like too much or whatever, the bottom line I'm saying is that the negative sign means pull. It means attraction. The reason we adopt this whole convention and we say all this is it's all in preparation for what we really care about in this class, which, if I'm scrolling down, which is the equation in the middle of the page, the bigger, bolder equation. It turns out that the way protons and electrons, it turns out the way point charges, little bits of charge in the universe interact with each other is strangely in the same physical and mathematical way. If you have any, and then this is what supposedly you discovered in the lab 2 days ago, I think, or I mean 9 days ago. If you have any bit of charge over here, say a big amount of charge, say Q1, and you have some other bit of charge over here separated by a displacement vector known as R, right? And so we're looking to see what kind of force the bit of charge over here exerts on the other bit of charge over there. In our mind, we draw this displacement vector R from one to the other. and we say to ourselves, okay, the magnitude of the resulting force, the force that exists here, is directly proportional to each of the charge magnitudes, and then it's inversely proportional to the magnitude of that displacement vector, i.e. it's inversely proportional to the square of the distance between the two charges, right? So all just the same as gravity. And then we multiply the whole thing by a constant, just like with gravity, we multiply it by a proportionality constant or a scaling constant to make sure that everything is in the correct units of SI, right? But then at the end of the day, we either find a plus sign or a minus sign at the end of the day, because at the end, and this is really why the convention really works, because at the end of the day, as you know from chemistry and all of that, if a proton is nearby another proton, then the force that the first proton exerts on the second proton, the force, if Q1 is a bunch of protons and Q2 is a smaller bunch of protons, Q1 will exert a force on Q2 that does push away from Q1. It's a push, it's a repulsive force, as you know, right? So if you have positive charge Q1 and you multiply by positive charge Q2, you get a positive number in the end. And the positive number means don't flip that vector. Don't come back to Q1. Recognize that the kind of interaction that we have here now is a push, not a pull. It's repulsion, right? And the same thing would happen if Q1 was negative, was a bunch of electrons, and Q2 was a bunch of electrons. If it were negative, you'd have negative times a negative means a positive. You'd have a positive sign for the whole thing, so you wouldn't flip that vector. So whether you have two bunches of electrons or two bunches of protons, either way, what we get is a pushing force, a repulsion, right? And it's only when we have positive times a negative or a negative times a positive that sign at the beginning will be a negative and we'll get attraction. Long way of saying, we now have a convention. I mean, hopefully some of you in the room sort of understood what I was saying about R before. Oh, and I left the thing off, but I left the carrot off that time by accident. But hopefully you're sort of following what I'm saying about the R. But whether you're specifically following the R thing or not, ultimately what I'm saying is from here on in, we have a consistent convention that applies both to gravity and electrostatics. The convention is negative sign means pull, attraction, positive sign means push, repulsion. And the math of the two forces works the same way. Other than that, I mean, I am going to stop talking soon, I promise, or I'll start writing, but I know I'm just talking into space right now. As the sheet tells you, the constant of proportionality for electrostatics is different. It's not the same number as the gravity number. It's a different number. And the units are, so it's a much bigger number. All other things being equal, the electrostatic force that exists between protons and electrons is actually far stronger than the gravitational attraction that exists between masses. Like all other things being equal, it's way, way stronger. But also the units of the electrostatic constant have to be in newtons times meters squared divided by the units of charge rather than the units of mass. The unit of charge is called a coulomb. A coulomb is how much charge approximately 16 quintillion protons have. One proton has a certain amount of positive charge. One electron has a certain amount of negative charge. Thank goodness they're equal to each other. That makes our life a lot more convenient than otherwise. But the amount of charge they have, if you're measuring in SI units, if you're staying in the same scale as meters and kilograms and everything else, the amount of charge that a proton has is actually tiny. Like you might think it'd be 1 unit of charge, not if we're staying in meters, kilograms, and seconds. It isn't. It's a tiny amount. The amount of charge of one proton is approximately 1.60 times 10 to the negative 19th coulombs. Electron is the negative version of that. And so that means if you're trying to picture what a coulomb of charge is, a coulomb spelled C-O-U-L-O-M-B, if you're trying to picture what a coulomb of charge is, you need to picture like about 16 quintillion protons jammed together into a tiny, tiny space. That's a coulomb of charge. Is that possible to have? Yes, it is. Protons are very, very, very small. Is a coulomb of charge like a lot of charge? Yeah, it is. but it's not an unreasonable, like crazily unrealistic amount. It is a lot, but it's not unrealistic. Okay. Oh, thank God something's in the chat because I'm talking way too much and I know it. Wait, sorry. Let me see. There's something in the chat. Can it be an equilibrium? Wait a minute. Wait. Oh, wait, sorry. Now I realize that the person who said it was tedious also said it made it easier. Well, that was nice. Thank you. Okay. I was so defensive about that word tedious. Like I went on for a half hour just because of that word, but okay. But anyway, but I'm looking in the chat. Someone's asking, can it be an equilibrium? I think that's a great question. I'm not sure what that means. I have a guess as to what that question means, but I'm so afraid that I'm going to make a guess, talk for 45 minutes, and then it's going to be the wrong guess. That wouldn't be the first time. And I am going to stop talking. We are going to do something, I promise. But what could someone, but since that is a question, could the person who's asking me, can it be an equilibrium? Or I'll quickly guess but could you tell me what you mean? I think do you mean, can the gravitational force and the electrostatic force like be balanced with each other? I mean, is that what you mean? Watch this. Oh, yup. Okay. Yup. Well, my answer is yup. I mean, no sarcasm. I was seeing let me just see if I can meet the challenge of having a quick. The answer is yes. I mean, you can. I kind of want to elaborate, but I don't know if I should. My short answer is yes, you totally can. Like, or my slightly longer answer. Watch this. My short answer is yup. My long answer is yup. No, that's so obnoxious. I'm sorry. That's it. But my slightly longer answer is actually that's what the universe is. Like if they couldn't be an equilibrium, like atoms would collapse. Everything would like if there were just gravity pulling everything together all the time. Literally, and I'm not being sarcastic about this. If gravity were the only fundamental force in the universe, everything would just crunch. Thank goodness there's also electrostatic repulsion, which keeps things apart. Now, I mean, there's also electrostatic attraction, which is what ultimately allows us, which is what is responsible for, say, like lightning, but also allows us to harness this electrostatic attraction and make things like circuits and electrical devices, which is like wonderful. But even if we weren't making stuff like that, it's electrostatic repulsion that kind of holds things apart. And the fact that the atom is stable, I mean, there's a lot more to it than this, but the fact that things are stable at all in the universe, that like you don't just walk around and collapse or explode all the time, I mean, no joke, is illustration of the fact that somehow these forces, thank goodness, can find equilibrium. Like existence, like is the equilibrium of these forces in a way. I don't know if that, but it is a great question, and we could say more about it, but I'm going to try not to for a moment. What I want to do right now, because I've been talking so much and I know I'm talking into outer space. I mean, I know I'm like not even writing these things down, is I'm going to take a small break from talking. What I want you to do, I mean, yeah, what I want you to do, I'm going to put you in breakout rooms now. I'm going to hold you responsible. I'm going to put you in breakout rooms. You don't have to work with the people in your room, but it might help. If there's anybody who physically is in the same space right now, like if some of you are at John Jay sitting next to each other, I'll put you in the same room. That's fine. Like, just let me know, whatever. But I'm going to put you in breakout rooms, and I'm going to hope that you have your Google Classroom accessible to you right now. This thing that's on the screen right now, part A, okay, like part A of the homework. It is the homework that's due next week. I'm going to ask you to literally do it right now. I'm going to tell you just part A. Just do part A. It won't take you the rest of the period at all. Honestly, it's a plug and chug. Hope it will not stress you out. Hopefully, I should never say that, but if using just literally the equation that is right here, this electrostatic equation, what this is asking you to do is, this is literally an example of tedious. It's going to ask you to plug and chug and get an answer for Roman numeral 1. And then it's asking you to do the same exercise 4 more times. I will tell you now, yes, part of the purpose is to practice the equation, but actually the purpose is to encourage you to cheat, not literally to cheat, but it's tedious enough that if you find any trick or technique at all for saving yourself time after you do the first exercise, if you find a way to not have to re-plug into the same equation 5 more times, then you're doing a good thing and you're in fact achieving part of the purpose of this. So I'm going to break you into, so this is not going to, so please don't wander away and get like a big gulp from 7-Eleven or whatever. Like, do this. We're going to regather in like about 25 minutes and we're going to assume that it's been done. And it'll be a big time saver on your homework. And we'll keep going with your homework from this to do as much of it as we can in this period. So, but do just this part A that's in the box, like 1 through 5. If you feel like you're getting out of plugging in over and over again, then you're doing the right thing, but get answers for all the home. Just looking in the chat. Where is it on Classroom? So it's home. Good question. I'll show you. So here's Classroom, right? I think you can see. Yeah. So if you go to homework 3, like we're up to homework 3, homework 3 fields, homework 5 from G to E fields, like due November 9th. Oh yeah, it didn't appear in your stream because it was an edit, whatever. Yeah, it probably didn't appear in your stream, but there it is. It's homework fields due. That's what I'm talking about. Okay. And then if you just click hopefully that answers the question. So I'm going to make, does it answer the question? Thanks. Okay, cool. Okay. So I'm going to make, first of all, I'm going to ditch this screen and we're going to go over this in like 25 minutes and please. And I'm going to say right now, just because I'm in that kind of a mood, I guess, I'm really going to turn it to you. Like, I'm going to depend on you guys to provide the answers when you come back. It's not hard. I should never say that. It shouldn't be stressful. Or if really you run into trouble, you can ask me questions or whatever. But here are the breakout rooms. But yeah, I'm saying like 4:45. 4:45, we're going to resume. Okay, here are the rooms. If you need me to switch something because 2 people are actually together in John Jay, that's fine. But here are the rooms other than that. And obviously it's random.